Okay, and we are live. So, welcome everyone to this Agent Intelligence kind of live stream, and we're super excited to speak about, AI agent builders, what's the future around the agent kind of like framework and landscape, and yeah, we are just inviting strong AI agent builders, ecosystem leaders, and yeah, for the people that doesn't know me, I'm Francisco. I'm leading developer relation at MetaMask and contributing to MotherDAO, and I'm a big fan of public attestation. This is something that we need, and yeah, I would say let's kind of like deep dive a little bit around the bio protocol. And Sean, it's a pleasure to have you here. I'm super excited. Do you want to quickly introduce yourself?
Thank you, Francesco. Yeah, my name is Sean Brennan. Been in crypto for a long time from MakerDAO. It's actually at Infura Consensus as well. And then recently joined the Bio Protocol to lead AI efforts. So there's a lot of interesting things happening in DeSci, and as these agents get smarter, you're starting to see people see what science they can do, what research tasks, multi-step processes, and love to dive into that.
Nice, nice. And for anybody, so welcome to the show, Sean. If anybody has any question, feel free to drop in the comments, and we will bring it up. So, and by the way, like I was a big fan, or I'm still a big fan of like the shy. Like I was actually like starting to check out like how is the landscape around different projects. Like I think that's something that is super needed, especially on the research side. And yeah, but let's deep dive a little bit in. Like so, Sean, like kind of like what was the problem? Were you kind of like initially solving or trying to solve with this agent, kind of like the pain points that you saw?
Yeah, so first let me explain what BioDAO is, or
Let's do it.
bioprotocol.
Yes.
So there is a new way for blockchain is a great way for decentralized funding, and many scientists, many small groups, small labs have unique research ideas, and the funding of biotech funding is just a lot of people say that it has hit a wall. There's certain problems with it, and
Yes.
BioDAO actually came out of Molecule, which is around
Mhm.
IP,
Mhm.
intellectual property, NFTs, and putting that on chain. And BioProtocol spun out to create many new BioDAOs. And so you're seeing
Nice.
things like Long COVID, HairDAO, SciDAO, and then the first was called VitaDAO, which is around longevity.
Yeah.
And these DAOs all have specific research goals. And even without AI, like if AI didn't take off and really increase in capabilities over the past years, BioDAOs would succeed. Like it's a new form of funding. It's getting many community members worldwide interested in these specific scientific problems that are more on the frontier.
Nice.
And yeah, like BioProtocol would succeed without AI. Why I joined is
100%.
because, of course, AI exists, and of course, it can accelerate science. So there's a few different, I guess, types of agents, two in particular that I'll talk about in this call. And yeah, really just it's about using these agent frameworks and giving them scientific tools or
Mhm.
skills or plugins in the ELIZA case, scientific plugins that let agents do scientific things, either looking at research papers, it could be creating hypotheses based on those research papers, and
Yes.
even what we're working on is adding in new connections to there's all these different virtual labs out there, like biotech labs, that you can make an API request and they'll complete an experiment for you and send you the results back. That could be
Nice.
hours or days later. And yeah, that's like
That's so cool.
kind of
And
like
but
yeah,
quick question, like, is the IP? Are you guys like pushing the IP on chain? Any specific kind of like protocol on the side, or
yeah. There's a site called Molecule XYZ,
oh,
which
molecule?
has
Yes.
been doing this for years.
Nice.
And the key piece about creating IP is that you have to make a claim. That
Mhm.
claim can be really anything novel, and
Yeah.
uh, the good IP is backs it up with evidence. And
Mhm.
obviously, there's claims of every type, and only valuable claims are really like able to be productized and turned into a therapy or a drug. And so yeah, it's basically easy to create claims, and it's about agents that as they get smarter, they can make better and better claims. And
Nice.
the we're kind of like right at the cusp where these agents are starting to make claims that are just like approaching the level of like the worldwide experts.
Mhm.
Um, but agents, of course, can be running 24/7. And the key thing that no one's really worked with yet is these agents have encyclopedic knowledge of tens of thousands of research papers, which humans cannot understand.
Oh yeah.
Like they can't just keep that in their working memory. And so that might be the biggest difference that people are exploring is that when agents have such a broad knowledge base, whether they can make insights that go beyond
I agree.
the
Yeah.
world, the world
I mean
leaders.
the yeah, I mean I'm starting to use like agents for not just like summary, but also like agent to agent. I'm thinking research for specific like kind of like could be paper research, not just I'm not speaking about like a GPT research thing like on the perplexity side. I'm really speaking about more about the agent to agent connection or even like a driving paper to other association. There is a lot of like different use case and. Actually, what are kind of like the low hanging fruit kind of use case that you see for those agents? And maybe we can deep dive actually in these two agents that you're speaking about.
Yeah, so we're calling them bioagents, and the first case, you're starting like you're saying with yes no error. There's other literature review agents that are taking scientific papers and performing some analysis on them. Uh, One initial step would be taking a paper and turning it into a knowledge graph, like a
Mm-hmm.
decentralized knowledge graph, especially in blockchain.
Yep.
And there's multiple kind of protocols for knowledge graphs specifically. We're going to be working with one, and like the very first foundational step is taking a long list of thousands of papers and turning into a knowledge graph,
Mm-hmm.
which is called a biograph. And
Yep.
that initial step is kind of important for fusion. Like future agents can more easily work with the knowledge graph compared to
Mm-hmm.
the massive text papers. It also has some benefits where the structure of the graph, maybe there's two nodes that might be close to each other, but there's not
Yep.
a edge between them, and that's like
Mm.
it actually comes across where like maybe there is a connection or like some undiscovered insight needs to find the edge that connects those two things. And so uh, basically playing around with creating the knowledge graph and then
Yep.
creating hypotheses to test based on the knowledge graph is
Mm.
the basically the first case where once we see agents creating hypotheses that are potentially valuable, uh, that would be awesome. That's what we're working on right now. And then of
Nice.
course the scientific process goes beyond just creating hypotheses. Of course, you have to test them, and then you create the IP, then you create the product. And so we're just starting with the initial steps.
Nice. Yeah, I think it makes totally sense. So what's kind of like the next things you mentioned like launching I'm definitely I'm not looking for alphas. I'm just trying to understand like what's the state around building but also most important like how was your kind of like builder journey around those different frameworks around those agents. Do you think like I mean where were the challenges about starting kind of building and shipping and I would love to hear more about that.
Yeah. So the past 2 years, I have been experimenting with things like LangGraph
Hmm.
or like LangChain, then their
Yes.
LangGraph and Llama Index, all these like multi-agent frameworks, Crew AI.
Yeah.
Um, these are, I think they're very, very useful, like Web 2.
Nice.
Um, I yeah, like a point is that I think there's going to be Web 2 scientist agents. Just like I
Hmm.
said, BioDAOs would succeed without AI. I think
Yeah.
there's going to be AI scientists that succeed without blockchain. And these can be inside Pfizer, like inside the
Yeah.
biggest firms where they're running scientific agents. Um, the the difference is that the world we live in has both these things. And so uh, what we're doing with bioagents is creating like letting people run agents at home, but they're part of a fleet of agents that a swarm or a fleet of thousands of agents that can do research on demand uh, based on the research tasks of the BioDAOs or potentially third-party biotech firms. Like if we do create this giant fleet of agents that can do scientific tasks, we're basically opening up a marketplace. And so Mother is very interesting. I think we can touch on that later. Um, and yeah, I think I
Yeah,
lost.
you respond. No, no.
Later.
The second kind of like part of the question was mostly like you being around for a long time, you kind of like nail down all these kind of like frameworks. Like what do you think around this kind of like AI agent? What were the challenges building those agents? Like I know that it's you're still cooking, right? But what do you think like for the all the AI agent kind of like builders out there that are listening to us in general, like what are the like is the fetching of data the problem? Is are the frameworks? Is the agent to agent standards that are not existing. What are kind of like the challenges that you kind of like find out and you solved?
Yeah, like so we're building these agents on Eliza to start with. And there's a few, of course, Eliza is changing very quickly. There's some V2 coming very soon. And so their team is doing the best they can to like help builders, but there is a lot of gray area in like what we're talking about is not deploying one agent that can do science. We're talking about deploying thousands of agents. And that like either a company can do that themselves and handle the like it's not very clear like the DevOps processes and the management of thousands of agents when like each agent can be doing its own things and there's just coordination problems and there's a lot of problems in like just going beyond one effective agent. Really, like you want two effective agents. You want to keep increasing that number, and the management of that is very, very new. And then again with like the tools, I said there's really no scientific tools like in every AI crypto framework. There's no tooling around scientific institutions. There's no connections there yet. No one is really creating scientific agents yet. I think this year, by the end of this year, it'll be incredibly different. Science, in the most recent blog post by Sam Altman, like he makes the point that the future is not evenly distributed. Like AGI is not going to evenly distribute over the basically the economies of the world, but the economy of science and improving science might be the quickest to change because once agents can reason about novel advancements and start to do experiments on their own, that process it might be strictly better than hiring a lab or like
of course, like much more lean, 24/7. Speaking, it's there is so many kind of variable that I think like people are not expecting. Actually, like one thing is you touch a bit agent to agent, but what's kind of like thinking about agent coordination, especially on the science side? Like because I don't see standards, I don't see frameworks yet, but because right now we're doing like human to agent or building humans build agents right now. But when kind of like agents will actually do the coordination side, how this will work? What kind of like you're thinking about that?
I think it actually has a connection to DPIN where the experimental apparatus is like the base layer, like the first part of any experiment comes from the data, and that data can be signed. And it's similar to like a chain of custody in like law enforcement, or like there's always a chain attaching some final result to the initial data. I think that can be an interesting way that agents can communicate to each other, where everything is signed, just kind of like a onion wrapper, where just you can always go back to the initial experimental data. I also would give a shout out to, I think XMTP is a very interesting protocol for agents to communicate. When agents have wallets, they can, part of what you're saying about like social verification and basically long running reputation, when agents they can be ephemeral. And it's like, how do you know an agent with one Telegram username is the same as the same agent with a Twitter username? And you really don't, unless they have the same signed message from a public key, that type of thing. So like I think XMTP is something that should be part of every agent orchestration toolbox. And yeah, that's a
nice. Yeah, makes sense. Makes sense. And I actually like what you said about maybe at the end of the year or even like in the next quarter, things will be very different. How like how you envision like kind of like the science research, like you think this will impacting like also let's say Web2 research academia. I mean, how do you think that the kind of like the space will move? I think like it's definitely like elliptic curve, like exponential curve, right? We're getting there so fast.
Yeah, and maybe this is biased view, but I think agents can be put to more useful work than shilling meme coins or shilling their own meme coin on Twitter. Like when, if we can prove that an agent spending its thought cycles, spending its time on advancing science is more valuable than shilling meme coins, that'll be transformative, where we won't see agent deployers that are just deploying agents with new tickers that just chat and like it feels like that space is very saturated. So one question is like, what are more useful things that an agent can do with its time? And yeah, I mean, there's probably no better. Some people would argue that there's no better pursuit than maybe longevity research. There's all these frontiers that are very, very interesting, and to most people at home, like it's not realistic to suddenly change your career or suddenly change that. But if you have an agent that you can just put towards helping that work, it's very, very similar to we're making the comparison that what we're building is compared to AlphaFold, Google DeepMind's process, their distributed process of protein folding, where they recently last year came out with AlphaFold 3, but AlphaFold 2 actually just won the Nobel Prize in chemistry for its work, and it's over 200. I think they like solved over 200 million proteins, and now there's 200,000 proteins in a public database. So that's very much like super awesome public good. And that was there's kind of a way how they use LLMs, like a specifically trained LLM to help solve the protein structure, but that it's not using agents, and it's using people's donations. People are donating their computer time, their electricity, in order to help Google. And it's an amazing result. But what we have to ask is, what happens if that program is actually running something agentic, which has a better decision tree? It can do multi-step processes. What tasks do we give it if there's an agent running at home? And instead of having it being donation-based, there's many different types of token incentivization schemes that you could work with to try to build up a decentralized network of agents that are pointed towards specific scientific problems.
That's interesting. And I think like you kind of like blowing my mind on the protein use case. What do you think is the differentiator? Like, because the reason why kind of like Mother is existing is that, you know, we're trying to build this kind of like social graphs around agents. So we know that your protein kind of like AI agent is not just a fork of the fork of the fork. So you have social attestation, you have a kind of a track record. So also the researcher, so the agent consumer of this agent will know which one is actually the true agent to trust, or at least like deploy or use. But what is the value proposition out there? Like, is the training of the models is the source of truth? Like, what do you think is like the differentiation of those agents when because it's always like the same. More vertical you go, like probably the biggest value prop that you can give is how you train the models. But maybe there is something else. Yeah.
Yeah, we're starting to see like scientific models where you can train. We're actually working with Prime Intellect, which I recommend checking out. They've done a number of things, but specifically one model that they've trained is called MetaGene1, where they trained a model for based on I think billions of pairs, like DNA pairs found from wastewater, and it's useful for kind of a outlier modeling for either like pandemic response. And there's many like specific biological use cases that in AI using that as a model could know, as opposed to using OpenAI's models or like Anthropic. Like those are general reasoning models, and now there's scientific models that allow a different sort of reasoning for AIs. I think more models like that are coming out, and with things like model routing based on the query, or based like you can have a general reasoning model that uses that model momentarily to solve a specific problem, and then it makes a research decision about like what experiment to design to create it. And you can go between these different types of models. But the fine tuning, so there's the fine tuning, there's the agent framework, there's the plugins and like the tools it has access to. I think all those are valuable. Yeah, we're trying to like use a general purpose agent, give it useful tools around interacting with biotech companies, and yeah, just letting it run for a long time, reviewing its hypotheses, reviewing its experiments, and basically have an expert opinion and proving that the agents can basically, because they're running 24/7, they can have a higher throughput and like
it's crazy. Yeah, it's
improve upon what a scientist is doing.
Nice. That's so interesting. I think also it's an enabler also of the researchers, right? I see already like first you're not just more productive, but also in a way, um, yeah, you just enable the kind of like efficiency on the research side. The question is, will be kind of like humans, go for it, go for it.
Yeah, like the way I see this kind of working is that I actually like interned at a biochemistry lab a long time ago,
Yeah,
and
yeah.
uh, like a common task would be like overnight. Uh, Usually, like overnight, you'd want to run a centrifuge for a very long run, usually be like 4+ hours, and at the next morning you came back and then you could work on the experiment again. And
Hmm.
this can be very similar, where you're at a certain stage of your research. At the end of the day, you
Yeah.
send it to uh, a fleet of agents to
Yes.
think of the next possible steps or run an experiment for you, and then you come back the next morning and all of a sudden like hours of work is done.
I think this is so efficient. I'm also asking myself when things are actually getting more complex and actually agents will be able to publish papers, review papers, backlinking papers. Like, what is the role of the human side apart actually like thinking about what topic to research? But I think we are still not there. But it would be interesting on that. Yeah. No, Sean,
Like
go for it.
sorry to like the because like right now, like maybe on Twitter, like there's the term like slop, or like it's just GPT slop. And
Hmm.
right now, like the things I've been describing, we basically have to prove that it's not slop, or that some percentage of things that come out of agents are not slop.
Hmm.
I think that's definitely true, but we're just setting out to prove it. But both, so you can have like a smarter AI on top of it to
Hmm.
like basically go through it and try to weed through the ideas and come up with the best ones.
Hmm.
Um, and like as the base models improve, like that level uh, is getting closer and closer to what you
Of
describe.
course.
It's not human level yet,
Yeah.
but it yeah, it's getting closer and closer. And so
That's
we're trying to
fantastic.
create this
Yeah.
decentralized network right now,
Mhm.
and 1 year later, it's going to be an even better decentralized network, and it can do more science faster.
Yeah, yeah, 100%, 100%. Yeah, because yeah, I see already. Like, I know it's not the same example, but I see already with low code dApps development, front ends, back end, even design to MVPs. It's so interesting. And I think on the research side, is I think like if we were speaking about kind of like decentralized science, what 6 to 8 months ago, with the kind of like AI agent era, things got really fully on kind of like on steroid and exponential, right? Because it's not just about the vertical; it's also about integrating. Agency and that's why also I think you will need more and more track record of which agent in the vertical on the decentralized science will be the one actually helping a lot because I assume there will be a lot of forks and a lot of kind of copycats, but the true kind of value prop will be done by which research lab will train the best the agents, right? And I think also there is also the factor that those agents will be trained based by organizations. I feel like academia will have a lot of like inputs, like maybe you will have agents specifically trained because if you look at right now, research is very siloed. Like let's say historic research is very siloed. I don't know. I'm from ETH Zurich, and you have a full kind of like library of research. Like I assume, like in other university, it's kind of they're like but I think even getting out of this open source research it's coming already. Yeah.
Yeah, and an idea. I know we're approaching time, but like I
Yeah.
shares that. Um, so like with Truth Terminal was maybe the first famous like Twitter
Oh
agent, and
yeah. Yeah.
that that one, the ideas to it were so new and like so alien because the creator had it running for months in a it called like an infinite back room in Discord, and they had agents talking to each other for months, and like
Hmm.
all these crazy memes and like
Hmm.
culture was created. And really, like you have to ask is like, if say ETH Zurich had an AI trained on all of its proprietary papers, and it's talking to an agent trained on Pfizer's proprietary data sets, and like what if you put them in an infinite back room and had them discuss biochemistry for simulated tens of thousands of hours? What would come out of that? And so like basically creating agents that are able to uh, reason about science. They have proprietary data sets. They can go further than you might expect.
Of course, yeah, of course, of course. Especially on the science vertical, I think it's super interesting. Especially because when you have like agents that may be more focused on the writing or maybe on the research side, the kind of agent coordination side is becoming even more important. Okay, sounds good. I mean, Sean, I think definitely like we need to have a part 2 where you actually demo us like some kind of like agent, because especially like on understanding what is happening. So definitely having a part 2. If you're coming to Denver, let's definitely like meet and having some kind of like demo. I think when is kind of like the official kind of like launch of this agent?
Yeah, we're gonna have a demo, like soft launch on March
Yeah,
1st. There's an event in Denver
nice,
uh, by OLAS,
nice.
OLAS.network, that will be giving a presentation on. And yeah, in the coming months, we'll also be in Berlin a month later. We'll be
Oh,
starting.
for DAFCON or what's happening?
The DAFCON, I think, is in June. We'll also
Oh
be
yeah,
there.
yeah.
And we're just going to do a small like virtual hackathon with like an in-person element in Berlin.
Nice,
Um,
nice,
and yeah, so this is going to be open source,
very
basically
cool.
improving the ELISA agent, improving the plugins it has access to. Yeah, we welcome
Nice.
contributors. So
Nice. Yeah, sounds good. Sounds good.
yeah,
We're having the live stream with Shaw, and speaking about integration and speaking about kind of like how to onboard more kind of like developers around the framework, I think is key. No, thank you so much. I mean, Sean, thank you so much. Thanks for everyone that is kind of like listening to this live stream. I think not just on the side on the bio protocol, but also this kind of like 2 agents that you're like cooking. It's super interesting to see, and I think it's one of the only. I mean, I told you before, right? I think I just spoke about with John Paller on the healthcare AI agent, and you're probably like the second person actually building on the research side on the bio side. It's super interesting, and I definitely see kind of like want to see the demo. And if you have links also of the event, feel free to send over. We will share it with everyone. And also remember, everyone, if you're building and you're listening and you're building this kind of like AI agent, or you're integrating with any specific like integration tooling, we're more than happy to hear your voice. We're running like different kind of there is different kind of competition and stuff. So make sure that you're reaching out. And we're also sharing all the links that also Sean is sending in there. And we're also running those how we say agent builder office hours. So that's also a good opportunity to share idea, pitch your agent, but also like listening for with listening other kind of agent builder that actually went into your same experience. Awesome. Thank you so much, Sean. And I probably see you in Denver. And thanks again for your time for this for our AI agent intelligence live stream.